Causation between IQ and national success is going to be our topic for Engineering 305's final project with Alexis Davies, Jessica Hausnick, and Jordan Stevens. So just an overview of the project. We intend to improve causation between IQ and national success. The Science Daily website defines IQ as a score derived from a set of standardized tests developed to measure a person's cognitive abilities or intelligence in relation to their age group. The GDP, or gross domestic product, is the monetary value of all finished goods and services produced within a country's borders in a specific time period. A nation's Human Development Index, or HDI, is a summary measure of average achievement in key dimensions of human development: a long and healthy life, being knowledgeable and having a decent standard of living, and geometric means of normalized indices for each of these three dimensions. Social Progress Index, or SPI, is a score that is related to the following three questions. Does a country have the capacity to satisfy the basic human needs of its people? Does a country have the institutions and conditions in place to allow its citizens and communities to improve their quality of life? And does a country offer an environment in which each citizen has the opportunity to reach his or her full potential? So the studies show that the nation's average IQ can change over time, which is known as the Flynn effect. This is saying that from 1932 to 1978, there was an increase almost a full standard deviation. So for the application is going to be to provide a rationale for or against fostering IQ programs. And one method to highly suggest causation is using related factors to the predicting factor and showing that they have similar relationships to the response variable. So a couple of the research questions are a nation's average IQ and a nation's success related? And then are a nation's average IQ and a nation's success correlated? And lastly, are GDP, SPI, and HDI downstream from IQ? What was the first cause? Now, going to our original hypothesis, we expect to find a highly correlated relationship between a nation's average IQ to a nation's success. Our hypothesis is that the higher the nation's average IQ, the higher the nation's success. We expect to see an exponential relationship between IQ and all three of these factors. We expect the IQ affects GDP, SDI, and HDI. Specifically, a high IQ causes or leads to high success indicators for a nation. Now Jessica is going to talk about the underlying data sets.
So these are the 5 underlying data sets that we used. We used average IQ by country. We used average years of education, which is the other predicting variable that we will use to predict success for a nation. And then we also got GDP, HDI, and Social Progress Index for the nations to measure their success by. And then while we were doing our regression analysis, we were trying to fit an exponential distribution to a graph of GDP versus IQ. We realized there were a few outliers. The first ones we looked at were China and Mongolia, which had high IQs but have low GDPs. And the reason that they're outliers is because they're communist countries, which causes the government policies to stunt the ability for people to have grow economically to the same rate as other countries. And the other 2 outliers that we looked at were Kuwait and Saudi Arabia, which have great natural resources, which also cause their GDP to be high, but also have lower IQs. So they also fall outside of the range of the other distribution of the other points. And we removed those from the data set as well.
So moving on into our analysis, our first big hurdle was to try and have a proof of causality. So basically what we did is we did a multivariate scatter plot matrix. We related all the variables. We related HDI, SPI, GDP, the average years of education, and IQ all together. And we have this covariance matrix, this scatter plot matrix right here. So basically, as we can see, these 6 right here are highly correlated because they're very close to a fit line. And this makes sense since HDI, GDP, and SPI are all measuring the same type of thing, a success of a country. As we move out into the rest of the scatter plot, into the 2 rows for the average years of education and IQ, it starts to disperse a little. This would kind of make sense since these are less loosely related to our measures of success, but they are do look like they're correlated by this RELM method. This is a clustering method that they use for their regression analysis. So we're going to try to move further into this and try to predict a nation's success based on the average IQ of that country. So our regression analysis will be composed of a linear, quartic, and an exponential model. So moving on, we have a correlations of all of them, and they all are above a 0.6 correlation, which kind of would lead to a proof of causality, since all of them are interrelated and they're all kind of related to each other. This would stem that there's something going on in the background, or there's something happening between these elements that one directly affects the other. So we are going to go into our first regression analysis, linear regression. So we just have an example in JUMP right here. This is the fit of HDI by average years of education. We have our linear model right here, and we have our R-squared value. Our squared value of 0.81 is really good. This is after we removed the outliers, and we have a mean squared error of 0.06, which is also very good. It's only a scale from 0 to 1. Moving on to the other models, we can see that for the ones that included HDI and SBI related to IQ in years of country, they're all above 0.64, which is really good, but they are not very good. They're 0.5 and 0.42 for the GDP. This makes sense because GDP looked like it had a non-linear relationship. We were predicting that what would probably be an exponential relationship. So moving on, we just decided to do regression analysis with the residuals. This was the second level of checking whether the linear models were correct. Typically, whenever you want to see if a regression model fits data well, we typically look at the residuals. What we're looking for in the residuals is we're looking for this to look like white noise, and we're looking for the histogram to look like a normal distribution, which it does, which is very good, which says that there is definitely something going on. There's definitely a linear relationship in that regression analysis, so they are correlated. After this, we decided we would do exponential, since that was our first guess and our hypothesis. So we did exponential fit lines in JUMP, and we looked at it, and they actually did not give very good R-squared values. And the graphs kind of just didn't really match the graph of the data very well. So this was kind of sad to say, but we decided to push on further and finally go to a quartic, which is a fourth power polynomial fit. Basically what happens is there's a constant, and then there are 4 powers, variables to the power of 1, 2, 3, and 4 with their coefficients. So as we can see, we actually got it up to a 0.67 R-squared value for the GDP and years of education, and we got up to a 0.62 R-squared value for the GDP by IQ. Now this is a lot better model, and this also shows that there is a nonlinear relationship between these variables, which makes sense since there's a nonlinear relationship between GDP and the other SBI and HDI variables too.
As far as insights and conclusions go, there's not enough conclusive evidence to completely attribute the success of a country to its IQ, but there is a relationship between IQ and the success of a nation. We might have had more conclusive evidence if we had gotten higher R-squared values, and if we had included more predicting factors that were similar to IQ that also showed similar relationships as was shown with the average years of education. As for our refined hypothesis, there is a relationship between IQ and the success of a nation, but IQ does not contribute to the entirety of a nation's success. We sort of saw this with the outliers, Saudi Arabia and Kuwait, where they had a lot of oil, which contributed to their high GDP, but even though they had a low IQ. Also, this was seen with China and Mongolia, even though they had a high IQ. Communism was a factor that caused them to have a lower measure of success, a lower GDP. Also, we'd expect to see as a nation's IQ increases, greater variance in the levels of success. And, we saw in the tail end of the quartic function, like the left part of the graph, that the nations with the lower IQ, in general, they had a much lower level of success. So they were closer together, clustered, less variance, and which supports our hypothesis, the fact that greater amounts of success, like lower amounts of success, or lower IQ leads to lower amounts of success, and higher IQ, well, that's greater amounts of success. That's could lead to a greater amount of success, but there is also variance. So now we're going to go into our demonstration in SaskJump. And these are references.
So this is our JUMP data. We have all of our countries. We have a total of 123 countries that we could get all of the data from. We have our HDI, our GDP, our SPI. These are the measures of success. We have our average years of education and IQ. These are the measures of intelligence, IQ. So we started off with doing a multivariate model and multivariate. So what we do is we do this, select this, and press OK. So this gives us all of the correlations based on an REML model. This is based on k-means clustering, and it gives us our data. So this is the first step that we chose whenever we were looking at this, was to look, okay, what does the data look like here? Does it look highly correlated or not? We did see the high correlation between these three, which makes sense. We did see less correlation between all of these, which kind of makes sense too. Another thing that we noted is that everything related to GDP has a non-linear looking function related to it. So after this, our second step we did was to do our regression analysis. So what we did for this is we did a fit Y by X models. We chose our HDI, GDP, and our SPI as our responses, and we chose our IQ and average years as our factors. This gave us 6 different scatter plots that we would regress on. So as we showed before, we would just need to do a fit line, and this shows the equation, shows the R squared value, and this seems like a pretty decent model to fit this. But whenever we tried to do a linear model of like this function right here, it didn't really fit very well. You can see that it doesn't fit very well either. So let's just remove this, and we did a exponential next. So we thought, okay, well, we need to do an exponential. So we exponentialed the x variables with linear, and we got a exponential model that still did not have as close to the values that we wanted. So after this, we experimented a decent amount. So we went to the fit polynomial in the quartic, which is the 4th power, which, as you can see, it more closely looks like the path that the data is following, and it has a higher R squared value. And we did this for both of the GDP models, since both of them seem to have the same relationship, the nonlinear relationship. This was the way that we attempted the data. We saw that the linear model fit the best for the SPI and the HDI related to the 2 input factors, and we saw that the polyfit degree equals 4 was the best model for the GDP for both years of education and IQ. So with that, that concludes our project, and have a great summer, Professor Rich.